Hello students, welcome back. We just went through the theory of t-distribution, and now let's go to an example problem. As for the example 3.6, this problem, actually I went it through in the optional videos of lesson 10. Here, I'd rather do the last one instead. Okay, here's a data set. The density of the Earth is known to be about 5.517 grams per cubic centimeters, based upon today's measurement, of course. Henry Cavendish, an English chemist and physicist who lives from 1731 to 1810, was the first scientist to accurately measure the density of the Earth. Here is the data set based upon his experiment conducted on 1798. Okay, 1798, it was a long time ago, but he ended up with this measurement. 29 measurements yielded the sample of 5.44793, approximately 5.448, and the standard deviation of 0.221, and the standard error, the standard deviation over square root of 29, the sample size, ended up with this. So we have the sample size and everything. Now let's answer the confidence interval and confidence bound problems. First, the confidence interval. We want the middle part, right? By the way, here is the sample statistics, the same computation we went through. And then the initial picture. Middle point, 5.448, yeah, that's the best point to estimate. Now I want the left-hand side endpoint and the right-hand side endpoint of this confidence interval. 95% in the middle, and we have 2.5% here and 2.5% there. How are we going to handle this? The typical method here is pretty much the same thing as we did for z-curve. Z is n minus center over SE. Yes, that was the formula, wasn't it? Therefore, n is, let's say, left-hand side endpoint minus the center of this, the observed mean. Or you can use 5.448 if you think 3 decimal digits is enough for you. And then the standard error, this over square root of 29 is this. And that's approximately equal to the z-score associated to 95% in the middle, or 2.5% in the left-hand side. That's what we used to do, remember? And what if I want the right-hand side? By symmetry, nothing changes except for the sign of the z-score. That's what we used to do for z problems. Now, we're looking for t-score for t-distribution. So this should change to t, and this z-score will have to be adjusted accordingly. How do we do that? Well, we have to look up the correct table, the t-table. This is a t-table. Recall that it's shaded to the right. And here is a z-table, and z-table is shaded to the left. See the difference here? Of course, the problem says it's c, and it says z, and it says z here all the way, and all these probabilities are there. Here the picture says it's t star, and right-hand side shading, and so on, all the probabilities. So we have to use this table. And because this thing is shaded to the right, I find it a little bit more convenient to work with the right-hand side endpoint. Now, t-table looks like this. To the left, we have the degree of freedom. So sample size minus 1 is 1, 2, 3, 4, all the way up to 30. and then jump to 40, 50, and then 60, 80, 100, and then 1000, and to infinity. All the way down here, the z value and t value have little or no difference. Now we have the degree of freedom of 28. Remember, we have 29 measurements for Cavendish experiment. So 29 minus 1, so we have 28. So that's the row we have to look up. Now, for the probabilities here, the upper tail probability of 2.5% is the one we are looking for. Let's go to this picture here. 95% here, so 2.5 to the left, 2.5% to the right. I need 2.5%, this column, and for the degree of freedom of 28. Let's go down, down, down. Do you see that? 2.048. That's one way to find it. Another way to find it is to scroll further and start from the confidence level. Start from 95% in the middle and then scroll up a little bit up to 2.048 at the degree of freedom of 28. Either way, it's going to be the same thing. So 2.048 is my t-score. That'll replace this. So 2.048. For the right hand side, it's positive. For the left hand side, it's gotta be negative. Oops. It's gonna be negative for the left hand side. For the right hand side, it's gonna be positive. Now, solving these equations, actually solve one equation and the other one, just change sign. Like I have here. I decided to go to the right, 2.048. And as a denominator, instead of using this computation, which we did earlier, here I decided to use s over square root of n. And then I postponed punching the calculator all the way to the last moment. Either way, it works the same. Flip denominator to the other side, all right? And then flip the center to the other side with this structure. Center plus the margin of error, t-score times SE. Here, the center minus the margin of error, t-score times SE. You see, remember this margin of error as z times SE, now t times SE. So 5.532 versus 3.634, yes, and thus we have this as a confidence interval, the 95% confidence interval. Make sense? What if we change this problem into not 95%, but something like, let's see, not 95%, but say 98%, 98% confidence level. So 98% in the middle, the other 2% must be shared to the left and also to the right. In that case, what do? Exactly the same method, except that we have to adjust the t-score. How do we do that? Let's go to the t-table, and instead of looking for 95% confidence level, we can start from 98% now. Go up a little bit, and then I'm getting 2.467 as my t-score. Or I could start from 1% to the right-hand side, and then go down to 228, 2.467, I could do that. And the t-table I'm going to provide you doesn't have all the confidence levels, 95, 96, 98, 99, like that. For example, 97% confidence level, and this table doesn't have it. So I'll avoid those kind of problems. So after adjusting this accordingly to other confidence levels, you can get it done. Now, do we have enough time for confidence bound? Let's try. Confidence bound look like this, sample statistic is the same. Initial picture looks like this. We want upper confidence bound, right? 95% upper confidence bound. 95% here, 5% to the right. So this time in the t-table, I have to look up 5% in the right-hand side. T-table, I have to look up 5% in the right-hand side. So go down to the confidence level of 28, go down to the degree of freedom of 28, 1.701. By the way, that corresponds to 90% confidence level. You cannot start from 95%. That's for confidence intervals. We want 5% to the right-hand side, and everything, including the left hand, all should be added up to 95%. So you should not be looking at this one. You have to start from 5% there for confidence bound. And it is 1.701. And that's a t-score you have to use. So indeed, I use that t-score and work out, and I have the upper confidence bound. Now, if I have to find out 5% or 95% lower confidence bound, then I have to subtract and then get the lower confidence bound. But then again, confidence bound problems are just one-sided only, so you don't really have to find both. I'm simply telling you how to adjust to change the problem, a different version of the problem. Okay, that completes the exercise at 3.7. And as for the exercise at 3.6, I covered it in previous lesson 10 optional videos, so look up to those.